Hi everyone, this is lesson 11-5. I am on page 782 and we're going to be looking at angle relationships in circles. Alright, so let's start by looking at theorem 11-5-1. What it says is, if a tangent and a secant, or a chord, it can be a secant or a chord, intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of the intercepted arc. Now, you look at the picture while I explain that. If a tangent, here's your tangent, and a secant or chord, this is a secant, but it could have been a chord if it had stopped right there. If the tangent and the secant intersect on a circle at the point of tangency, so they intersected right there and created an angle right there at the point of tangency, then the measure of this angle is going to be 1/2 the measure of the intercepted arc. This is just like the inscribed angles that we studied in the last lesson or a couple of lessons ago. So our angle is going to be 1/2 the measure of the arc. Again, this angle is going to be made by a tangent and a secant or chord. And the formula would look like angle ABC is equal to 1/2 of arc AB. Angle ABC is equal to 1/2 of arc AB. Okay, let's look at an example with that. Let's apply it. Example 1A. Find each measure. We want to find the measure of angle BCD. So let's look at this diagram. We're looking for angle BCD. So we're looking at the angle that I have marked right here. It's not the 90-degree angle. The 90-degree angle is ACD. So we're looking for BCD. And as you can see, it intercepts arc BC. That means, according to our theorem, that this angle is going to be 1/2 of this arc. Here's our formula. And when we do half of arc BC, we're going to get 71 degrees, or half of 142 degrees is 71 degrees. So this angle BCD is 71 degrees. The next question, B, asks us for the measure of arc ABC. So here is arc ABC. It's just a little bit bigger, arc ABC. This one's pretty simple because they tell us that that arc intercepts a 90-degree angle, ACD. So we know that the arc is going to be twice the angle. Therefore, if the angle is 90, the arc is going to be 180, and you will see that right here. Angle ACD is going to, you know what, I completely read that backwards. Okay, let's erase that. We won't worry about that part right at the moment. We don't need it anyway because we did it in our heads. Okay, we'll just overlook that. All right, so we know that angle ACD would be half of arc AC, or arc AC is twice angle ACD. So if the angle is 90, the arc is 180. Okay, let's look at A. Check it out. This is at the bottom of the page. Find each measure. We're doing the same thing. This time we're finding the measure of angle STU. Let's find angle STU. It's this one right here. And this one should be pretty easy because we have an intercepted arc that goes with this angle. Remember, the angle is going to be half the intercepted arc. So half of 166 degrees is going to be 83 degrees. Now we want to find the measure of arc SR. Here is arc SR. And again, this one is made pretty simple for us. We have an angle made from the tangent and the secant or chord, and the angle is 71 degrees. So our theorem tells us that the arc is going to be twice that. So that's going to be 71 times 2, which is 142 degrees. All right, moving on, let's look at the next theorem. I am now at the top of page 783. This is theorem 11-5-2, and what it tells us is that if two secants or chords intersect in the interior of a circle, which you can see that these do. These are chords, and they intersect in the interior, meaning the inside of the circle. Then the measure of each of the angles is formed by half the sum, right here, half the sum. That means the answer to an addition problem, half the sum of the measures of its intercepted arcs. So let's look at that. Angle 1, of course, is going to be congruent to this angle because they are vertical angles. And these angles are going to equal 1/2 of AB plus CD. Let's look at the math on that. Angle 1, or its vertical angle, are going to equal the two arcs, their two intercepted arcs, added together and divided by 2. So that's really quite easy. We're just going to say, we're going to find their intercepted arcs. Here's one, here's one. We're going to say this plus this divided by 2, and that gives us the angle measures for these. If we had wanted to do this angle, which of course would have been equal to this angle, we would have said arc AC plus arc BD divided by 2, and that would have given us the measure of this angle and this angle, which are, these two angles are congruent, again, because they're vertical angles. All right, we are going to skip the proof right here for the sake of time, but let's go down to example 2, finding angle measures inside a circle based on what we just learned in our new theorem. Find each angle measure. We're going to find SQR. Here's SQR. I'll put a little dot there. Hold on, it's hard to do when I'm looking at it through the phone. Okay, they've given us the information that we needed. We're simply going to use the formula. We're going to say one arc, one of the intercepted arcs, plus the other intercepted arc, times 1/2 or divided by 2 means the same thing. So that's 132 divided by 2 equals 66 degrees. That means this angle is 66 degrees and this angle is 66 degrees. Now, just a reminder of how all of our geometry overlaps and works together. We could then find this angle by using this straight angle and saying 180 degrees minus the 66 degrees right here, and that would give us this measure. Okay? All right, let's look at the check it out. There are two check it outs that go with that. And the first one is find the measure of angle ABD. So here is angle ABD. We're going to repeat exactly what we did. Of course, ABD is congruent to EBC, and to find either one of those, we're going to add the two intercepted arcs, 65 plus 37, and multiply it by 1/2 or divide it by 2, means the same thing. And 65 plus 37 divided by 2 equals 51 degrees. That gives us the answer to this angle and to this angle. And then just like above, we could have found this angle and this angle simply by recognizing our straight angle is 180 degrees. Say 180 degrees minus this equals that. Okay, let's look at the next one. Find the measure of angle RNM. RNM. So we're finding this tiny little angle. You can see I've already done all the work. So let me figure out what I did, and then I'll talk you through it. Okay, I see where I started. I didn't have any information on this arc's measure, or let me put my pencil a different way, or this arc's measure. What I did have was this arc and this arc. So I decided to use those and find angles MNQ and RNP. And I did that by saying 225 plus 91, you can see the work right here, divided by 2 gives us 158 degrees. So that gave me the measures that I needed for those two. Then I was able to find MNR by doing exactly what I told you. I looked at my 180 degree straight angle running from R to Q, and I said 180 minus 158, you can see my work right here, equals 22 degrees, and that's how I got that answer. All right, flipping the page to 784 introduces a new theorem, so I'm going to stop the video and start on video 2.